Okay friends, today we will discuss about Open System Interconnection Model, which is also called OSI Model. OSI Model is simply a reference tool, a standard reference framework for conceptualizing data communication between networks. OSI is a layered model. It divides the network communication processes into 7 layers. Each layer performs some specific functions to support the layers above it. OSI was the first conceptual model that characterized and standardized the communication functions of a network system without regards to its internal structure and technology. OSI is a modular model. Different vendors can work on different parts of the network and then combine them together to form a system. An important point worth of mentioning here is that although OSI is the standard, but we never find it on real equipment. The model in action today is TCP/IP. OSI is used only for standardization and reference purposes. OSI is a vendor-neutral model. Before OSI model, each vendor used to use its own network model to manufacture network equipment. So one vendor's equipment and network was not compatible with another vendor's equipment. Buyers were bound to buy only from one vendor. For example, if you were buying IBM computers, then you were bound to buy all network equipment from IBM as well in the future, because IBM computers couldn't be connected by other vendor switches or routers. So you must buy IBM switches to connect them together. They will not work with HP servers or Cisco switches. So this was a problem. To resolve this problem, the idea of a standardized network model emerged. International Organization for Standardization, ISO, started working on it. Different network models were proposed, and finally the OSI model was chosen and released in 1984 by ISO. OSI brought in the flexibility along with standardization. In simple words, OSI reference model describes how information from a software application in one computer moves through a network medium to a software application in another computer. OSI model has 7 layers starting from physical till the application layer. Physical layer standardizes the physical medium. For example, signal levels, voltage, radio, cabling standards, and so on. It simply standardizes everything which we can touch and feel. Physical layer is responsible for ultimate transmission of digital data bits in the form of electrical, optical, or radio signals from the physical layer of a source or sending device over the network communication medium to the physical layer of the receiving or destination device. Data link layer standardizes the physical addressing. It is responsible for data switching. Physical addressing includes MAC address and Ethernet frames. Network layer deals with logical addressing. It is responsible for data routing. Transport layer ensures the error-free data transmission across networks. It mainly focuses on data delivery. Transport layer mainly uses 2 protocols, which are called TCP and UDP. We will discuss these in later. Session layer is responsible for session control. In simple words, it manages on how to start, control, and end conversations between 2 hosts or computers. Presentation layer is responsible for data organization and conversion so that it is readable by application layer of all hosts applications which are involved in the data communication. Application layer is responsible for end user application and processes. It supplies network services to end user applications. Transmission of data happens between systems from layer to layer. Let's look into this layered approach through sender and receiver model as shown here. These 7 layers are divided into 2 groups. Layer 1 to 4 are called media layers or lower layers. Layer 5 to 7 are called upper layers or host layers. Media layers are responsible for networking. Media layers handle data transport issues. The physical layer and the data link layers are implemented in hardware and software. The physical layer is responsible for actually placing the information on the medium. Host layers or upper layers are about applications. Upper layers deal with application issues and generally are implemented only in software. During data communication, user data is passed from layer to layer and control information comprising header and trailer is updated at each layer. So each layer has different unit of information. This combination of header, trailer and data is called PDU or protocol data unit. Now every layer has a different name for these PDUs. They are called bits on physical layer, frames on data link layer, packets on network layer, segments on transport layer and data on all application layer. So these are different names for PDUs at each layer.
Please click on the link in the description to watch the second part of this series.
Thanks for watching this video. Please subscribe to our YouTube channel and Facebook page for more and updated videos.